Now another important reagent is Brady's reagent. Brady's reagent 2,4-dinitrophenylhydrazine. In short, it is called DNP, dinitrophenylhydrazine. This reagent also react with aldehydes and ketones, same as before. That means eliminating 1 molecules of water. Say if you take aldehyde and 1 molecules of hydrazine H2N, and hydrazine was NH2NH2. So in lieu of hydrogen, or instead of hydrogen, there will be a 2,4-dinitrophenyl group. This is phenyl group. This is phenyl group. Now 2,4. This is 2 position, NO2, and this is 4 position. 1, 2, 3, 4. This is called DNP or Brady's reagent. That means 2,4-dinitrophenylhydrazine. Then 1 molecules of water will be eliminated, and the product will be CH3CH double bond N NH, then this group NO2 and here NO2. This is called hydrazone, and this compound is formed as a solid crystal. That means you will get a precipitate, yellow or orange precipitate. Yellow or orange precipitate you will obtain. So you can observe a yellow orange precipitate if you add Brady's reagent to aldehyde or ketone. As these reactions are all for carbonyl group, so by this test you can prove the presence of carbonyl group in an organic compound, because you are getting yellow precipitate or orange precipitate. Yellow or orange precipitate depends on the concentration. You may get yellow or may get orange precipitate. This is also in your syllabus, where you will do in practical identifications of aldehydes and ketones. So for theoretical questions, you will get how will you identify the presence of carbonyl group in an organic compound. You will identify by Brady's reagent getting yellow or orange precipitate. Next, reactions of ammonia with aldehyde or ketone. Aldehyde and ketone will react similarly. So I am giving an example with aldehyde only. CH3C double bond OH plus NH3. What will obtain? CH3 CH OH NH2. These is not carbon reactions of like hydroxylamine. NH3 reacts with NH, H and NH2. H is positive and NH2 is negative. So here carbonyl group, oxygen becomes negative, carbon becomes positive. With carbon, OH will form, one hydrogen will come here, and positive charge NH2 will come here. This is aldehyde ammonia. Aldehyde ammonia, additive compound. Both aldehydes, ketones and also benzaldehyde react in this way. Aldehyde reacts with 1 molecule of ammonia, forming aldehyde ammonia. In practical life, 3 molecules combine to form trialdehyde ammonia. Now, if the first member of aldehyde, this is formaldehyde, first reaction you are getting formaldehyde. Common aldehyde is acetaldehyde. Acetaldehyde is the second member of aldehyde group, and this is the first member of aldehyde, is for formaldehyde. If you take formaldehyde and if you add ammonia, then there will be a different type of reactions occur, and you will get a new compound CH2 N4. This is called hexamethylene. Hexamethylene tetramine or urotropine is medical name. It is used in medicine. So this reaction occurs in different way. Formaldehyde with ammonia, urotropine. This is important compound as this is directly used as a medicine. You also have to know the structures of urotropine. This is hexamethylene tetramine. I am showing the structures of hexamethylene tetramine now. And trivalent, this is trivalent nitrogen, CH2 methylene group. There are 6 CH2 group. CH2 group has bivalent, so one this valency and another is this valency. Then it will be placed another with nitrogen. This nitrogen will combine with this nitrogen, so CH2 group. This nitrogen will combine both with this methylene group. This nitrogen will combine with this nitrogen. Now you see there are 6 CH2 group. 1, 2, 3, 4, 5, 6. 6 CH2 group and 4 nitrogen. 1, 2, 3, 4. 4 nitrogen. This is called CH2 N4 tetramethylene. Hexamethylene tetramine. This is the structure of this compound. You often ask in question, draw the structure of hexamethylene tetramine. Now today I am concluding up to this.